says MP is congruent to NP, which means I have to do what to my diagram? Mark it. You've got to get in the habit of marking your diagrams. Okay? The next one says, well, actually I should say this. From there, is there anything else I can do about those segments, about that one given statement? Is there anything else I can come up with? No, there's nothing left for me to do here. That means I go to my next statement. My next statement says that QP bisects the angle. QP bisects angle MPN. Where is that angle? The bottom of the diagram. The bottom, yeah. Now, some of you guys wrote that down, but then you wrote down the wrong angle. You wrote down the wrong angles that were marked up. So when you know that you have something that's bisected, obviously your progression sheet says state the angles that are congruent. Because you'll have congruent angles for them. So what we do, we go to figure out which ones they are. By marking the diagram, it forces you to make a notation to where the angles themselves are congruent. That's the idea. We did it, we wrote it down. And that's just the definition of an angle bisector. On the first question on the quiz, you were given a segment bisector. Many, many, many of you wrote angle bisector for your reason. Just careless. Just be careful. Read it. You had plenty of time. Every one of you guys finished with plenty of time ahead of you. Okay? The progression sheet that we use, the how-to, if you will, told you you had an angle bisector, creates two angles that are congruent. We mark it on the diagram, and we're done. These first three steps, you didn't have to think about it because it's all that sheet of paper. Now you get to the point where you have to think of something. After you go through a few of these parts, then you have to say, okay, according to my diagram, I have a side and I have an angle next to it, which means I have to find an angle on this side of it, or a side on this side, or an angle on this side. What do you have? We have a side. Which side? QP. And why is QP reflexive? Yeah, not shared side.
Yeah.
On the progression sheet, it says look for the shared side, but you didn't write. That means take your sheet out so you can put on there it's congruent to itself because the reason reflexive property. So put it on your sheet. Now you have triangles. Because of side, angle, side. That's the idea of how you string it together. It hasn't changed in the 2 weeks or so that we've been working through these. It's just a matter of reading the stuff because you really only had to come up with one step. But what we do today, now that we know that the triangles are congruent, I want you to think about when we did stuff like this. When we said we had two triangles that were congruent, we knew that the corresponding letters, how they matched up. Remember doing that the first day? If it's A, B, C, and X, Y, Z for the triangles, A matches with X, B to the Y is C and Z. We did all that. We knew that segments AB would have to correspond to XY. BC would have to be YZ, and so on. Those would be then their corresponding parts. We knew all of that occurred at the very beginning. We went away from having to label everything out to now where we're at here again, where I can say, where was my diagram? Angle M is congruent to angle N. That's the next natural step in this. Since I have two triangles that are congruent, These two have to be the same because they correspond to each other. The lettering matches out. Oh, I wrote MQP. It should be N. Sorry. I wrote that incorrectly as I was writing it out. So your letters, the angles match. Okay? Yes. And this is what we're talking about today. It's called corresponding parts, congruent triangles are congruent. That's new today, and that's what we're going to talk about. I'm going to write it out again. Or actually, I want you to put it in a square. Basically what this gets at, guys, is that once we state that you have triangles that wind up being congruent to each other, that means that all of the corresponding parts have to be equal to each other. They have to be congruent to each other. So it goes from the idea of the first couple of days of talking about congruency, having to show that everything was congruent to each other, to whittling it down, just having to show that you had two sides and an angle, or two angles and a side, or three sides, or some mixture of those, to now saying that after I go through it, I can go ahead and say then that all the corresponding parts are congruent once I have triangles that are congruent. It's the next step in what we're talking about, how we're working through some of these things. When we get going, you'll see that it's not any different from what we started with. We do all the same work. It's unscented. It's just my knuckles break the crack really bad. It's gross. You guys right there. So here's what you get. We can take any proof. And instead of just proving that we have triangles, we're going to prove that we have a part. We're going to prove that we have a part. And that's what we're doing today. This is, I don't remember what section they call this in the book, but I know it's basically called cpctc, corresponding parts of congruent triangles are congruent. And again, with the whole acronyms and stuff, that way we don't have to worry about writing all of it out. I don't remember the number, but I know it's in the next, it's just the next thing. I've kind of been jumping around between all the different numbers as it is. I know we started around 4.3, 4.4, 4.5, but this textbook kind of blends everything together. So it's still in triangles. Okay, but we've been in like 3.4. We've been doing a whole bunch of it. Don't worry about what specific lesson, like what section it is out of the book. Because if we do stuff in the book, I'll tell you the pages and all that. It's all in the same chapter. It's all in that 4. So it's like 4.2 through 4.5, somewhere in that neighborhood. We're kind of piecemealing it together. So what I'd like you to do is let's go through and write up and draw the picture of your diagram. Have your progression sheet out. Let's walk through and make sure we know how we set it all up to make this work. Now, if I'm not mistaken, I think was perpendicular one of the first ones we did. It's probably the third one. Okay. So the perpendicular one, I think, was the third one that we did. But if you remember, when you're looking at having perpendicular, you have to be given perpendicular to make something work. Whereas some of you guys on your quiz, you were saying that you had perpendicular, but you've never had that shown to you. Okay? Some of you guys were drawing it in on your diagrams without knowing that it was there. Okay? You can't just assume something is without doing it. Because remember, no acid. So we start with the perpendicular statement. All right? According to your progression sheet, what do you do now after you have perpendicular? What would you like to put here? What about statement? Remember, what that means is that we need to go through the diagram and write down what are the right angles. That's what it means to state the right angles that are formed. We go through and we look at it, and most of you guys can just draw the little box in there and say, okay, but what are the letters for? And when you write down something about an angle, you have to use the angle symbol. So we would say angles A, B, C, and angle D, B, C are right angles. Oops. On our sheet, it doesn't say, hey, write down that they're equal to 90. Don't say that they form a little square in the box. It says, quite literally, state the angles that are formed. Those are my two angles that are formed. I have to use three letters. I can't just say angle B. All right? And the reason then, after I state it, well, I just use the definition of perpendicular. Okay? I did not say that they're congruent to each other. I didn't say any of that. I have to do that first. If you don't have that written down as your first step for the progression sheet, please make sure you change that to be your first step on the progression sheet. Okay? Now that you have them, then you say that they're equal to each other or congruent. Because all right angles are congruent. The process we put them through. Time is nowhere.
Pretty well yourself.
All right.
218?
Sure.
Good job.
Thank you, sir.
Not a problem.
Today.
You too? Want to get fired? That's what it meant. Back in the day when you got a pink slip, it meant you got fired. That's what it was. That's what it was in the HR term. That's what you ever heard that?
Yeah,
You got a pink slip? Was it in Mulan?
Yeah. When in the second one?
Oh, I don't remember. I didn't see the second one. It's funny you brought Mulan. My kids just watched that the other day for like the first time. They loved it.
Yeah,
It does. That's
because
good.
when she was going to get married. So it's like, oh, here's a pink slip.
Nice. Anyway, so according to your progression sheet, there is nothing left to say after you have those right angles. After they're congruent, you're done with that. So now you go to your next statement. Shh, guys. You go to your next statement. BC bisects angle C. Again, we have the angle. So you go to your diagram right away. You look at the diagram and think, okay, an angle bisector bisects an angle, which means it creates two angles that are going to be congruent. So we go to the diagram, we look for C, we mark up the two angles that become the same. When you mark it up first, then you can say, all right, knucklehead, What were the letters that created that angle? Well, A, C, B. And the other one, D, C. Definition of an angle bisector. We're using the definitions, the terms, all of that to create a flow to make this work. That's why we call it a progression, because as you go through the order, that's what allows you to set it up. That's how this stuff works itself through. If you ask around, make some pictures, write something down too. You need to write pictures. Okay. Now, if you look at your diagram, it wasn't an invitation. It's like literally ask somebody to write with something. Something to write with, take something out. Be helpful. Not rocket science. Rocket science is a lot harder than this. You have two angles in a row. You have two angles in a row, which means you have to find a side on either side of those angles, or you have to find a side between them. What can you state? Yeah, the reflexive, yeah. You have the reflexive right between it. So that means you're going to wind up with an angle, side angle. By having the diagram drawn out as you're going through it, it forces you to look at that bottom corner of the different letterings. Which one do I have? What somewhat of a pictured idea do I have? Okay? Remember, not all the diagrams will look the exact same. It's just how the lettering matches itself out. Okay? We're just looking for that. So we know that we're going to wind up with that by saying that BC is congruent to itself. Okay? Here's where things are going to get a little bit different today. Before, it was mainly write down the triangles and go for it because it told you exactly what triangles to show that would work. Today, a lot of times, it's not going to tell you what triangle to write down. It's going to have you find a part. Well, if I'm just trying to find that angles A and D, well, I know that angles A and D are part of a triangle, but what I have to do is write down my triangle letters so that they match up with the angle letters. Does that make sense?
Yeah.
So if I say that I have triangle ABC, looking at my diagram, I went with no tick mark, right angle to the tick mark.
Okay.
See how that goes? What would have to be the corresponding letter for the other one?
DBC.
Yeah. You have to just be conscious of how you write your letters because you want to make sure that your lettering would match out if you started to do all the corresponding parts. That's really the only trick to this. You do all the exact same stuff, but at the very end, when you get to your triangles, you have to be very careful in how your letters match. You get your letters to match, you know these two triangles are congruent because of the angle side angle. And once you have triangles that are congruent, that means all of the corresponding parts are congruent. So I wanted to say that angles A and D were the same. Well, I can now. Because, go ahead and say it. Yeah, cpctc. I know, it's acronyms of things and stuff. Well, you don't have to remember it because you have your progression sheet. You have your progression sheet out. Make sure you put it on there. That's the idea. It's not that you have to be able to do all of this without that sheet. It's how are you going to be able to use that sheet to get you to where you have to go. And it just takes a little bit of time.
Yeah.
It's right on.
I don't know. I didn't pay attention to it.
good person. Yeah, we did. We were all done. Yes, ma'am. I wanted to draw this picture larger because this is the one where we have parallel. And for most students, historically, proofs when we have parallel lines tend to be the craziest ones to figure out. Okay? Now, I'll let you write that out real quick. And I'm going to show you, again, a really nice, easy trick to help yourself with the angles. Okay? And it'll work on this one. It'll work on the diagram you guys had on that quiz. Which I think was I think it was that, wasn't it? These guys were parallel. I'll show you the trick on both of those. Because honestly, a lot of times when you have parallel lines, you kind of get the same thing over and over and over again. I'll show you how. Ooh, is that a jerk? Yeah, BA is parallel to CD, BC is parallel to AD, and then I want you to prove that CD is congruent to BA. Sorry. No. And that's cool. That's fine. I don't know if you guys heard what Ken was asking. When you put the two letters down for segments, you have to put the line on top. It's okay. That's fine. Then it gets. As you notice, you have so many symbols and so many things. You start putting. If we can get rid of not using a few of them, it makes them look a little bit cleaner. So that's one thing I'm fine with. Now here's our trick. I'm just going to draw this real large for a second so you can kind of see why this works and it's helpful. Now, we know that AB and CD are parallel to each other. Okay? So when you have parallel lines, we know that we would put these little arrows on it, correct? Good. Now, what I always suggested that you guys do was draw a Z. Here's why. If I draw a Z, my top and bottoms are the parallel, the diagonal is the transversal. Okay. Notice where it changes direction. BAC is an angle. DCA is an angle. You guys see that? Yeah. Where it changes direction, here and here, are your congruent angles. Those are the alternate interior angles. Okay? That's how that works itself out. If I go the other direction, now it said BC is parallel to AD. See how it flips to the other side? Yeah. Just by where the angles match, where it changes direction, it shows you which ones will be the same. Yeah, and that happens a lot. So you'll see that the Z could be forward, backwards, upside down, where it looks kind of like an N, or backwards N, or whatever. But if you make the idea of a Z, like a zigzag or whatever, where it changes direction, is where you get the congruent angles. It's a nice trick to remember. Okay? So if we went back to what we did the other day with the quiz, if you follow through the ones that are parallel, you get your change of direction here and here. Okay? If you follow the change of direction going the other way, you had them here and here. There's a couple of ways to do that, just by drawing the zigzag through it, where it changes direction. There was a couple of ways you could have done that one. I think it wound up with you had midpoints here and here,
Yeah.
and then if you did it this way with both of those, you had angle, angle, side. Some people did with vertical. Most of you guys did with vertical angles, and you got angle, angle, side this way, and that was fine. Either there's a couple, and some people did angle, side, angle because they got the other twos from the parallels. There's a couple of different ways to do that problem, all right? But it's the idea that you take the diagram, you draw the zigzag to figure out where they change spots. When you see where they change spots, that's why I keep telling you guys, geometry is so unbelievably visual. All of this stuff is. It's marking things on a diagram to follow letters. Okay? So if I go back into here, and I start with my given and prove statements. BA, parallel CD. Given. BA, CD gave me those two angles. I write them out. Angle. BAC, congruent, angle, DCA. Notice how I'm starting with that, when I say angle B was the starting point of it and came down, that means the opposite one would be at D going back up. The reason here is, move this over a bit. If two parallel lines are cut by a transversal, you have to put that down. You have to have that symbol there. Then, with all the arrows, yeah. Then, alternate interior angles congruent. Gotta have all that on there. Some of you guys just wrote alternate interior. Yeah, great, they're alternate interior. But what are they? And why were they created? Why are they congruent? Make sure on your progression sheet that you have all those parts to it. I know that our squares said, look for angle pair relationship. Well, you got to be careful with that. That way you can find them correctly. Right? I do the same. Yes, sir. Yeah, you have to. Sorry, you might not be your constraint. Yeah, you have to build a symbol there because that's the reason why they're congruent. Because the parallel lines are there, then they're going to be. So just make the symbol. Go to the next one. BC, parallel AD. We do the same idea. Change directions, we're here and here. And it winds up being the exact same reason because we created those angles because of the Z. Zigzag your way through. So we have our, if two parallel lines were cut by a transversal, then the alternate interior angles are involved. You have two angles. How are you going to find the side? Yes, sir. Yeah, we're flexing. We're flexing. AC. Now, when you label your triangles here, if I start by saying triangle ABC, if I say triangle ABC, what has to be the corresponding letters for the other one? What is it? CDA. The reason why it has to be CDA is I'm starting at A to B to C, and I have to do 1, nothing, 2. You do this twice, 3 times, you're like, oh, yeah, no. It doesn't matter where you start, you just got to make sure they match. We have angle, side, angle. And then I think it said what show that CD was congruent to BA. Yep, and there you are. Let me go through. Okay. So we're still doing the exact same stuff. The only thing that changes is that we have a last step. Okay. I have a couple of these. And you'll probably notice that 2 of them look eerily similar to what we just did. Oh. I do. Yes, it should have been. Yeah. Good catch up. Yeah, that's right. Yeah, this should have been AB the way the letters went. You guys see how the letters went on this one? It went C to D. So this one should have been A to D. I didn't catch that. Sorry. Thank you for catching that. On this, you're doing basically the same thing here, guys. On number 4, I want you to prove that, what is it? Cross out what they have to prove. We don't need to worry about proving rules. Let's prove the angles. Do that for 4, and then on number 5, add another, like also prove angle R is congruent to angle W. Okay? So you have number 5, oh, forgot right now, what number that was for, number 5. On number 5, it tells you to prove that you have triangles RST and WUT. I'm just asking you to also prove that you have angles R and W. Okay? So basically you have 4, again, of these. And we'll see how we do. We'll do more of them again tomorrow. Ma'am.
Okay, the one that we changed this for.
No, you can just leave it like that. That's fine.
Can I just follow you?
No, I would hope you would. Okay? We'll build out of this. We'll do a little bit more of this fun stuff tomorrow. Like I said, we got a couple of days of this to do.